Okay, hopefully you put the letter orders as triangle TKS. So we went from D, the blue side, to green angle to red side, so that was DKA. So we have to go from blue side to green angle to red side, so that's TKS. Okay, what I would recommend you do if you didn't already naturally or instinctively do it is I would just pause now and try some of these other ones on your own. And then once you look at it carefully on your own and try to figure out, are these triangles congruent and why are they congruent? Is it ASA, SSS, or SAS? Then you can come back and check your answers with my video and see if indeed you did get the answers correct. Okay, so letter D. Letter D, I have a single mark here for TR, a single mark here for AR, and a single mark here for RG, which means all three of these pieces are congruent to each other. Well, then if I look at TA, that's a double mark here, and AG, that's a double mark here. So what do we have? Well, we have an isosceles triangle TRA, and we have an isosceles triangle ARG. Do you think those two isosceles triangles are congruent to each other? Well, hopefully you're saying yes, because their legs are congruent to each other, right? These two parts, these red sides are congruent to each other, and these blue bases are congruent to each other. So yes, these two triangles are congruent to each other. The question is why, and in what order do we write their letters? So this first triangle is started off as triangle TRA. So we go from T to R, which is the red part, and then the red part, and then we have the blue part last. So it's T to R to A. So going here, probably most of you are going to say, okay, well, I'm going to go from G to R to A. G to R to A. That's fine. Is GR congruent to TR? Yes, it is. Is RA congruent to RA? Yes, it is. Is TA congruent to GA? Yes, it is. So therefore, you did do it in the proper order. Why is this then justified that these two triangles are congruent? Well, hopefully you're saying that's a side, side, side. The only thing I outlined there are sides. Some of you might assume that this is a 90-degree angle here, but we don't know that. There's nothing on this paper that indicates that that's 90 degrees. So you cannot make that assumption. Now, did I have to write my triangle as GRA? Well, hopefully some of you are thinking, no, I didn't have to do that. I could have went A to R to G. This is also congruent to triangle ARG. Well, let's see if that's true. Is TR congruent to AR? TR, AR, yes, they're both red. Is RG congruent to RA? RG, RA, yes, they're both red. Is GA congruent to TA? Yes, they're both blue. So either one of these written triangles was fine. Okay, moving on to letter E. We have DK is congruent to TK. We have angle AKD is congruent to angle SKT. And we have AK is congruent to KS. So hopefully you can see blue, green, red, red, green, blue. That's SAS. The side, the angle included in between them, and the other side. So these are definitely congruent. Why? Because of SAS. Now let's look at the order of the letters. We go from D to K to A. It's blue to red. So we have to go from blue to red. So that's triangle TKS. Again, if you're not getting this, and then get out your markers and color these sides. I think it will really help, especially for those of you that are visual. Okay, let's look at the next one. We know TR is congruent to RG. We know this is a 90-degree angle. And if this is a 90-degree angle, well, the one right next to it also has to be 90-degree angle because that means AR is perpendicular to TR. So therefore, there's 4 congruent right angles all the way around it. And then the last thing that people often forget is this shared side. AR is congruent to AR. Let me keep it red because that's what I've been using the whole time. So AR is congruent to AR. So are these two triangles congruent to each other? Yes, they are. It's red, green, blue, or blue, green, red, green, blue, green, red. So why? Because it's side, the angle in between them, and side. So it's SAS. So what do? I start at T. I go from blue to red. So I have to start out here at G and go blue to red. So that's triangle GRA. Okay, letter G. This time it's very important to notice these symbols right here, which mean parallel lines. So that means that CA is parallel to DR. And if CA is parallel to DR, then we have the letter N here, or the letter Z, which means we have alternate interior angles right here. And then we have this segment, which has 1 mark, and this segment, which has 1 mark. So those must be congruent to each other. And then we have this shared side right here. So that's a shared side. So hopefully, again, you can see SAS, blue, red, green, SAS. So why are these two triangles congruent to each other? Because of SAS. So what do we have? The order of the letters is DRC. We go blue to green. So what do we need to start? We need to start up here and go blue to green. So it has to go from A to C to R. So triangle ACR. C has to be second because it has to have that red part right here, right? That's their common angle. So C has to line up with R over here. So these angles we know are congruent. So they have to be in the same order on your paper. Okay, last one. Triangle SOT is congruent to what? Well, let's see. So what do we know from this diagram? We know here, this is double side, this is double side. Those are congruent to each other. Here we have ST is congruent to FL. And then our final thing is this angle. We have vertical angles here. Right, so this is the vertical angle theorem, which tells us that those two angles are congruent to each other. So vertical angle theorem. So what are we going to do then? We should go green, blue, red, or red, blue, green. So if we went red, blue, green, that's side, side, angle. That's side, side, angle. Side, side, angle. Or that's angle, side, side. If you're going around, remember we go around the edges. You can't start with this blank. You can't go, oh, side, skip one, angle, then side. It can't be like that. Remember, this A would not be the included angle between these two things. This A is not the included angle right here. So therefore, it's side, side, angle, or angle, side, side. Notice this naughty word being spelled out. If you spell out the naughty word going around. Okay, so you can't ever write the word ass on your paper. We would never accept this. That is inappropriate. So therefore, that's not a justification. So this does not enough information. We cannot prove two triangles are congruent here because this does not show that two triangles are congruent. You either have to have SAS, SSS, or ASA. And this angle that was given was not an included angle, therefore that was not a justification for making two triangles congruent to each other. We will learn more theorems for why triangles are congruent, but right now today we're just focusing on SAS, SSS, and ASA. Okay, so let's do a proof. So we have a couple of proofs here. So triangle proofs. We're going to try to prove that two triangles are congruent. So what are some steps or some tips to do that? Well, step number 1, you might want to mark the diagram with the given information. That's always helpful. Like I've been marking it with my colors. You might want to keep doing that. Number 2, mark any additional parts that are congruent, such as vertical angles or sides shared by both triangles. So we have common sides and we have vertical angles, right? Common sides here, shared sides. If helpful, label angles with numbers. So you can always tack in the numbers 1, 2, 3, 4. It's so much easier than writing angle BAC. You could just write angle 1. Number 4, decide which method to use. Are you going to use SAS, SSS, ASA, which one of those? And then we write the proof. So proof writing 101. Step number 1 is always your given. So look what's given here. We have angle 1 is congruent to angle 4, and we have angle 2 is congruent to angle 3. Okay, now if I'm following these steps, I'm going to mark that information. Angle 1 is congruent to angle 4, and then separately angle 2 is congruent to angle 3. Okay, great. So right now I have an A and an A. So I have two A's. Well, if I look up here at my list of postulates, the only one that has two A's is ASA, which means I'm going to try to find the big fat S to go in between. That means I'm trying to prove that the included side is congruent to the included side. Well, the included side, remember, is the side that connects the two vertices to each other, and that's side AC. Well, side AC is the included side, so side AC is congruent to side AC, right? Side AC is in triangle BAC, and side AC is in triangle DAC. Now, why is AC congruent to AC? Well, going back to the algebra properties, that's my reflexive property. And sorry, I forgot to write in row number 1. The reason that this is true, my justification for this, is just your given. The fact that it was given up here. So my justification, these are justifications, remember? Reasons are justifications. The reason or justification is that it's given. The reason this is true is that it's the reflexive property. Now your final line in a proof is always what you're trying to prove. So this is what you're trying to prove. So here we're trying to prove that triangle ABC is congruent to triangle CDA. Okay, well let's check that out. We went from A to B to C. So we went from red angle to nothing on the angle to green angle. So we have to go from red angle to nothing on the angle to green angle. That's CDA. So do the vertices line up with the way they should? Yes, they do. Now, why are these two triangles congruent to each other? Because of angle, side, angle. Because of angle, side, angle. So my justification for those two triangles being congruent is ASA. Now, did we have to write triangle ABC is congruent to triangle CDA? No, it's also true. I was doing before, I might have done 1, 2, 3. I might have done ACB. You could write that. Triangle ACB is congruent to what? Well, if we went from A to C to B, we would go from red to green. So C to A to D. Again, look, A lines up with C. We have all these same vertices lining up the way they were in the previous one. So it works. But you don't need to do this. I'm just showing you that you can write your triangles in a variety of ways. It doesn't always have to be ABC, but this is what's given, so that's why we write that here. Okay, number 2. Let's mark what's given. Okay, BE is congruent to EC. So we have BE is congruent to EC. So I'm going to mark that on the diagram. And then I have AE is congruent to ED. I'm going to mark that on the diagram. And then look at these triangles. I'm trying to prove that triangle AED is congruent to triangle DEC. Oops, AEB, my fault. I totally highlighted the wrong one there. AEB is congruent to triangles DEC. So these two triangles right here. So are these two triangles congruent? Yes, they are. The final piece, I have a side and I have a side. So I have a side and I have a side. I either need my third side to make it SSS, or I need the included angle to make it SAS. So if we have the red and the blue meeting, well, the included angle is right here. The included angle is right here. Are these two angles congruent to each other? Yes, they are. Why? Because they are vertical angles. So now we're going to fill out our proof. Step number 1 is to write the given information here. What's the justification? It's because it's given. Step number 2 is to identify the third piece. The third piece was the angle here. So we could put a 1 and a 2. So that's angle 1 is congruent to angle 2. Why? Because it's the vertical angle theorem. Okay, that's my VAT, vertical angle theorem. And then my conclusion, well, my conclusion is just what's here. I'm trying to prove that AEB, triangle AEB is congruent to triangle DEC. And why is that? Well, we just said it's going to be SAS. So SAS is the reason. Try the last one on your own.